In software development, we've got this huge problem. We spend weeks, sometimes months, writing these incredibly detailed documents that are basically outdated the second a developer starts to code. But what if? What if that document was the developer? That's the huge shift we're going to dig into today, moving from these dev documents to living, breathing DNA that actually builds our applications for us.
I mean, this quote right here, it just nails it. If you've ever worked in a big company, you know the pain of the solution design document. It's this massive file that, let's be honest, nobody fully reads, and it's absolutely impossible to keep up to date. So this isn't just some prediction, it's a declaration. It's saying that this old, broken way of working is finally coming to an end. For decades, this has been the process, right? Write everything down first, then build it. But that's like trying to fit a waterfall model into an agile world. It just doesn't work. These documents create a massive game of telephone between the business folks, the architects, and the developers. And the result? They become obsolete before the first line of code is even written.
And what that does is create this massive disconnect. The specification was basically treated like scaffolding. You build it, you use it for a bit to get started, and then you just throw it away once the real work of coding begins. This always leads to drift, inefficiency, and building products that don't quite match what was originally planned. Okay, so what if the spec wasn't temporary scaffolding? What if it was the permanent blueprint, the actual DNA of the application itself? Well, that is the core idea behind this brand new approach called spec-driven development. It completely flips the script. And here's where it gets really wild. The specification stops being a passive document that you read. Instead, it becomes an active engine that builds. It's a living, breathing thing that directly generates the working code for you. And this, right here, just perfectly sums up the whole mindset shift. In the old world, code was king. Period. Everything else was just a suggestion, a guide. But in spec-driven development, the spec itself is the ultimate source of truth. The code, that's just the natural outcome of executing that spec. Now, let's be clear, this is not about writing some magic one-shot prompt and just hoping for the best. No way. It's a structured, disciplined process. You start by defining the intent, the what and the why. You set up principles and guardrails to guide the AI, and you refine the whole thing in multiple steps. It's a true partnership with AI, not just a handoff. Okay, so this all sounds amazing in theory, right? But the big question is, how do you actually do it? Well, guess what? This isn't just some abstract idea anymore. GitHub has gone and released an open source toolkit called SpecKit that gives us the real, practical commands and structure to build software this way, like right now. And here it is. This is what that workflow actually looks like in practice. It's like having a structured conversation with an AI. You start by setting the constitution, the fundamental rules of the road. Then you specify what you want. You plan out how you'll build it, you break it all down into tasks, and finally, you just let the AI implement. Every step is a clear command, taking you all the way from a high-level idea to real executable code. When you start working this way, it's not just your workflow that changes. It goes way deeper. It fundamentally changes the very things we create along the way. Our development artifacts, they evolve from these static documents into something much, much more powerful. So we're leaving behind those, dead-on-arrival PDFs and Word docs. Instead, we are literally crafting the genetic blueprint of our applications. This DNA is structured, it's machine-readable, and AI agents can use it to build, maintain, and even govern the entire system. It's a total game changer. And this table just lays out the evolution so clearly. That static PDF design doc, that becomes policy as code that is actively enforced in your pipeline. The Visio diagram that's outdated a week after it's made, that becomes a living, interactive knowledge graph. Manual risk assessments? Nope. Now we have auto-generated compliance checks. The shift is from static snapshots to live, dynamic systems across the board. So let's just drill down on two of these because they're really cool. Policy as code means instead of a document that just says all data must be encrypted, you have a rule that automatically fails a build if the code even tries to handle unencrypted data. And a knowledge graph, it isn't just a picture of your architecture. It's a live interactive map that the AI can actually use to understand how every single piece of your system connects. It's like giving it a GPS. So, when all your tools and all the things you create are changing this dramatically, well, it's pretty obvious our jobs are going to change too. Our roles as engineers and architects are absolutely going to evolve. And this right here, might be the biggest shift of all. It's about us, the humans in the loop. Our value is no longer measured in lines of code written. Instead, our primary job becomes being the architect of intent, carefully crafting the system's DNA so that AI agents can handle the heavy lifting of implementation. And why does this matter so much? Because it is a massive force multiplier. It empowers you to operate at a much higher level of abstraction. You get to focus on the big picture stuff, the architecture, the business goals, the strategy, the why, and the what. You provide the blueprints, and the AI agents become your tireless implementation team, letting you scale your impacts like never before. So that leaves us with one final question, and this one's for you. Look, this isn't science fiction. This isn't some far-off future. The tools are here today. The shift from writing static documents to architecting living, executable DNA has already started. The only question left is, how are you going to write the DNA for your next project?